Hello, welcome to Oracle DBA02pro.com. This is Hassan Mir. In this tutorial, I'll be talking about blocks. Okay, so let's do a quick recap. We have database files on the hard disk, and the files could be grouped logically into table spaces. Logically, table spaces can be broken down into segments, and segments usually represent one table or index, or maybe one sorting unit in the temporary sorting unit in the created by Oracle. And one segment can be broken down further into logical unit extents, and extent can be further broken down into blocks. Okay, so forget about database for a while, and let's talk about bits. What is a bit at operating system level? Okay, let's talk about raw operating system. Bit is the smallest memory unit that can contain either 0 or 1. So you can think of bit as a small wire on the computer hardware. If there is a current in the wire, then it's 1. If there is no current, then it's 0. And that is in reality what a bit is. Okay, and but bit in itself can only contain either 0 or 1. That's not very meaningful, because we want to store more meaningful information like characters, right? Like A, B, C, or look at your keyboard. There are so many different characters. Bit is not enough for that. And the way computers are designed, that's how they work on 0 and 1 basis, right? So what we need is we need to group all the bits together, like multiple bits together, to come a byte, so that we can store meaningful information in byte. Usually byte consists of 8 bits, but that's not hard and fast rule. Okay, and it could be different from one operating system to operating system. This could vary, but anyway, let's imagine that byte consists of 8 bits. Now a byte can contain itself in itself something more meaningful. For example, this is a ASCII character set. Just an example, there are multiple character sets, and the whole purpose of character set is to define how would you store a particular character in a byte. There's a UTF character set, there's a Unicode character set. Anyway, so ASCII character set is like 7-bit character set. So for example, if you want to store A in a byte, you would store 1 in one bit, 1 in another bit, then a couple of zeros in subsequent bits, and finally 1. So this would make like in hexa number A, right? So look how we are combining 1 and zeros to make something meaningful. Okay, so one byte usually consists of 8 bits, but that's not a hard and fast rule. It could be, as I just said, 2 bytes could be, representing one character, for example. But anyway, you got the concept. We are still talking about operating system. We are not talking about database yet. Alright, so usually one byte represents one character, as we have already talked about. Now let's talk about blocks. What is a block? Okay, block is a unit consists of multiple bytes. So significance of a bit is it stores 0 and 1. Let me go back one slide. Significance of byte is it stores something more meaningful because it combines lots of bits together. And let's talk about blocks now. Blocks consist of fixed number of bytes per operating system. When you create per file system, when you create a file system, at that time you can define at the operating system level, of course, how many bytes will a block consist of. Okay, it could differ from operating system to operating system level, and you could have multiple choices. You could change the default value as well, but the bottom line is that at operating system level, a block on the hard disk would consist of multiple bytes, fixed number of bytes. Okay, for example, a block may consist of 1024 bytes or 512 bytes. Now what is significance of a block? Significance of a block is when something is like some program running in the memory needs some information from the hard disk, the whole block has to go, one whole block has to go from hard disk into the memory. Even if you need some minor information from a block, minimum one block will be read. Okay, so significance of block is it's the smallest unit that will be read into the memory. So if the block size is too big, for example, a block consists of too many bytes, then lots of information will be going into the memory, even if you not need the whole thing. Now let's talk about database now. With this background, try to imagine what database is. Database is nothing but files sitting on the hard disk. Okay, we're not talking about database instance. We're just talking about the database. Instance are database management programs running on the memory. Now, database resides on the operating system file system. Okay, so there is something called database block size. So far we are talking about operating system block size. Okay, so when you create a database, at that time you define something called database block size, and you can only define database block size in multiple of operating system block size. Now let's say operating system block size is 512, then database block size could be either 512, it could be 1024, it could be 2048, but it cannot be 256. Why? Just try to imagine we have a database program running in the memory, and database program needs one database block from the database. Now one database block means when database is read, minimum one database blocks will go from hard disk to memory. Let's say you have defined the database block size as 256 bytes, and at operating system, the operating system block size is 512. So that means database program running in the memory will ask the operating system, because it's running on top of operating system, right? So it can't just read the database directly. It has to ask the operating system to send information from the database to the memory, because database sitting on the operating system file system, right? So the database program will request the operating system, hey, send me 256 bytes. Operating system will say, hey, I minimum I send is 512. Either you take 512, either you take 1024 or maybe 2048, but don't ask me to give you 256. I don't do that. So that's why database block size has to be in multiples. Minimum you can go is operating system block size. Okay. Now here's a recap. Basically this is take home. Minimum one operating system block size will go into the memory when hard disk is read. Okay, but when database is read, which is nothing but program on the hard disk, but since database instance running in the memory will read the database. Okay, so when database is read, minimum one database DB block will travel from hard disk into memory. So one DB block could be equal to one operating system block, or could be equal to two operating system block, or could be equal to three operating system block. Who's requesting this information? Database program in the memory. And now database program in the memory can request operating system to send either one OS block or two OS block or three OS blocks. So if one DB block is equal to three OS blocks, that can easily be handled. Okay, but you can't request one half OS block as one DB block. So anyway, so when you create a database, you have to basically when you create table spaces, right, you have to define what would be the block size, and usually it's capped like same block size as the operating system, but you can go double or triple. Okay, so that would mean like whenever database is read, minimum one DB block will go into the memory, so that could translate into two OS blocks going into the memory, or three OS, whatever you have size, DB block size you have defined in the initialization parameter file. We haven't really studied about initialization parameter file. Just understand that initialization file is a file that tells the instance when it's waking up, right, in the memory, that what would be the environment variable. So whatever information you put in the initialization file, that file is only read at the time of database waking up, and that can control the behavior of the database. Okay, so anyway, just for your information, you can have a setup where one table space is using one DB block size and another table space is using different DB block size. Okay, that can be, I think there's a limit of 4. You can have up to 4 different DB block size, but that's beside the point. That's like advanced topics. But the whole purpose of this tutorial was to give you a concept of operating system block size and database block size. Okay, and what's the relationship between the two. So that's pretty much it. I'll see you in the next tutorial.